I want to start today by talking about something that's very difficult for some students when it comes to written response work. And this could be written response questions on exams or assignments. Very often on exams or assignments, you're asked to explain something. And giving me a narrative of what you're doing to get an answer is not a mathematical explanation. So really the way you should look at the difference between describing, which is what some of you do, and explaining, which is what I'm asking for. I'm not sure why that says why you did it. I should say why you did it. And this is directed mainly at the people who, when you look at your assignment that you got back, there's a comment beside some of your work that says more needed. Or sometimes I'll just write the word why. So explaining what you did is not a true explanation, it's a description. For example, on that assignment, you were asked to write out the domain and range of the inverse of the original function. And a lot of you kind of said, well, this is what I did. When I find an inverse, I switch x and y. You gave me a narrative of what you're doing. So, and that's fine. That tells me you understand why what you're doing is working, but you're not explaining it to me in words. You're not actually explaining the why in words. And the explanation is that the definition of an inverse is the result of some kind of reflection across the line y equals x. And that means that there's mapping involved, which is that x comma y becomes y comma x. Unless you elevate your response to something that tells me about the definition of an inverse or the meaning of an inverse, it's not good enough. Another example would be when talking about the fact that the inverse is not a function. A lot of you just said, well, the inverse fails the vertical line test, so it's not a function. Or you said the original fails the horizontal line test, so it's not a function. And if the inverse fails the vertical line test, that's true, it's not a function. And if the original fails a horizontal line test, that's true, it's not a function. By the way, before I explain what you should be putting, if I were you, anytime you explain something in science or math for a marker, never use the pronoun it. Because a lot of you on your assignment says it fails some test. And I don't know what you're talking about. I don't know if you're talking about the original or the horizontal. So in technical explanations, you need to avoid the use of the word it and instead say specifically what you're talking about. But in order to get full marks there, you have to tell me that you understand what a function is. A function produces 1y for every x. So something that fails the vertical line test, like the inverse does here, produces multiple y's for a single x. And I guess all I would leave you with before we get started today with the homework and the new lesson is make sure you understand that when I ask you to explain something, you don't merely tell me what you did. You tell me what you did and you back it up with a reason why what you did works. You need some kind of why in your response there. So I hope that helps with the assignment. The assignments were pretty well done for a first assignment. You'll get better and better at them. And don't forget that your assignment number 2, which is 2 problems, is due, pretty sure I said Wednesday. I'll tell you what, I'll take it in Thursday. You know, if you need an extra day, that's fine. So I'm just going to say that if you want, you can change the due date for assignment number 2 to be Thursday, but you're not going to get them back and marked by Friday. It will be after the weekend. So now we have to go back in time a number of days to what we did on Thursday. And what we did Thursday was we dealt with solving trigonometric equations. So you can get your books organized in front of you, all of your work organized. We had some questions that were from the textbook that you could have been working on. We had some questions in the handout that you could be working on. These were primarily trigonometric equations. The idea is you take, I'll do one here as an example to kind of bring our brains back up to speed. Let's do C, 21C from the textbook on page 217. And whether you did this one or not, it doesn't matter. I'll rewrite it just so it's a little bit larger and you can see it a little better. Actually, I'm rewriting it so that I can see it a little bit better. It's 6 cosine squared of theta plus 1 cosine theta. And then it's equal to 1, so you have to subtract the 1 to the other side because, well, when you solve a quadratic equation, your first step is to zero the equation. The domain is 0 to 360. So we're going to want answers in degrees, anything between 0 and 360, but not including 0 or 360. So your first step is to factor this. This is what we would call a complex quadratic equation, what I would call a complex quadratic equation. What I believe Mr. Hetlinger and Mr. Flynn call a type 2 quadratic equation. What makes it complex in my mind, or type 2 in their mind, is that the leading coefficient is not 1. So if it were 1 when we factor these little beasts, it's pretty straightforward. We just put cosine theta and cosine theta, and then we find numbers that multiply and add. But here it's more complicated because of that 6. So if I had to take a stab in the dark, which is the method I use, trial and error, I would say it's probably going to be 3 cos theta and 2 cos theta, but it may not be. The two numbers that I put have to multiply to give the 1, so there's not much of a choice there. With a little bit of thought, I can see that if I put a positive in front of this one and a negative in front of the other one, if I were to FOIL it out, I would get the 6 cos squared when I did the first. I would get the negative 1 when I did the last. And when I multiply the outer and I multiply the inner and add them, I would get positive 1 cos x for the middle term. And I hope you would agree on that. I'm just double checking it myself, but that's right. So now what you're going to do is you're going to create 2 linear equations. Can I get I just want to open up my chat window on my other monitor. Can I get somebody or a couple people to verify that they believe that's factored correctly? Okay, so that's good. I'm glad I asked this because there was a bit of a delay between my question and the responses, and I think it was more than the lag of, all the electrons moving around. I think I just reminded you that you have to actually be thinking while you're doing this. So don't just sit there and take my word for it. Do the work on your own. Now what we're going to do is the same thing we would do in Math 20. We write that each factor now is equal to 0. And then you solve each factor. So we've turned it into linear trigonometric. I'm glad I chose this example actually because we end up with cos equals 1/3 and cos of theta equals negative 1/2. The reason I'm glad I chose this, and it was by accident, is that the equation on the left cannot be solved by using the unit circle as we know it. There is no x coordinate on the unit circle. Remember, cosine is x. There's no x coordinate of 1/3. Well, it's there, but we just don't know what angle produces it. Whereas the equation on the right, we could use the unit circle. So if you're going to use a reference angle, and you can follow along here, you're going to have to find a reference angle for the first equation. Theta reference would equal the inverse cosine of 1/3. And we want degrees, so we don't have to fumble around with radians here. So we're going to take the inverse cosine of 1 divided by 3 and get 71 degrees or 70.5 degrees. If you chose to take a reference angle approach in the second equation, which there's nothing wrong with doing that. You don't have to rely on the unit circle. You would take the inverse cosine of 1/2. Remember, you wouldn't include that negative, but can I get a few people to verify for me that you get 60 degrees for a reference angle? Thank you, Aaron. So then what you would do, if you took the reference angle approach, then what you would do is you would look at the fact that in the equation on the left, cosine was equal to positive 1/3. And that means your reference angle of 70.5 degrees is going to be sketched or drawn in the quadrants where x is positive because cosine is x. And that means you're going to plot 70.5 degrees or draw it in quadrant 1 and in quadrant 4. And then your rotation angles for that first part of the problem, first part of the equation would be this green arc and this green arc. So one of the angles would be 70.5 degrees. The other would be found by taking 360 minus 70.5. You can figure out what that is. In the case here where we had cosine equals negative 1/2, since cosine is negative, you would be talking about sketching the reference angle of 60 degrees in quadrants 2 and quadrant 3. So your two rotation angles would be this and this. The first angle would be found by taking 180 minus 60, so you'd get 120 degrees. The second one would be 180 plus 60. You'd get 240 degrees. Over here you'd have 70.5 and 269.5. I don't know. Can you subtract that for me? 360 minus 70.5. No, I think that's, yeah, 389.5 maybe. If only there was something I could use to find out the answer to my question. 289.5, thank you. I should have just used my calculator. So 289.5. Anyway, that's the gist of it. Certainly with these two angles on the right, you could have found them using your unit circle. Excuse me. So take a minute here. I'm just going to mute my mic for a second. And I'll be back in like less than a minute, and we'll go over any questions you have. Sorry, I just got a bit of a tickle in my throat. So any questions from any of the assigned problems dealing with quadratic trigonometric equations or these complex trigonometric equations? (3A) in the booklet, okay? So we want to algebraically find the solutions. You don't quite know why it says algebraically, because as far as you're concerned, everybody, there is only one way to do it algebraically, but we will learn there's another thing we can do later this week. So when we look at this, we see that there's a quadratic nature to the trig equation. Specifically, there's sine squared. And since there is a quadratic term, a linear term, and a constant term, it's a full-blown quadratic equation. What we need to do is zero the equation and attempt to factor it. So it's going to be 6 times sine squared of, I'm going to change this, Lauren, to theta. Is that okay? And good. And I would recommend, if you are at all confused about the fact that there might be x's in an equation, but x is related to cosine on the unit circle, this is a perfect example of that problem. Like when you talk about sine, which is what is in this equation, you're thinking of y coordinates, and yet the letter x is being used for the angle. So change it to theta instead. So we've got 6 sine squared theta minus 5 sine theta, and then I add 1 to both sides, so I get plus 1. Why not? We're here. We got lots of time. Let's do the b squared minus 4ac calculation. So I would like each and every one of you to calculate b squared minus 4ac and see what you get. I get 1. Colton gets 1, Amy gets 1. Well, if I got 1 and Colton and Amy and Daniel and Chloe got 1, I'm guessing it's 1. Everybody else should be getting 1. It's negative 5 quantity squared minus 4 times a times c. So that would be negative 5 in brackets squared minus 4 times a, which is 6, times c, which is 1. This works out to 1. What's the significance of that? 1 is a perfect square, which means it's factorable. And again, it's 6 sine squared, so I'm going to guess 3 sine theta and 2 sine theta. And it's going to have to be 1 and 1. And if I'm right, that 1 times that 1 has to give us a positive. But the inner terms and the outer terms together give us a middle term of negative, which means these have to both be negative. And I would ask everybody to just verify here that if you FOIL this out, you do get 6 sine squared. We'll do this together. If I multiply this out using FOIL, my first will be 6 sine squared of x. My last will be negative 1 times negative 1, which is 1. And I'll bring the whole thing into the mix here. My outer will be negative 3 sine theta. My inner will be negative 2 sine theta. So this is my outer and inner. And you can see that everything that we've got when we FOIL this out matches what we have above. So this is an interesting question because it turns out to be basically the same, almost the same factorization as we had in the example I chose before. But it's also very different because of the 2 pi, the 0 to 2 pi thing, because we have to be in radians. And that's what makes this tricky. So getting back to you, Lauren, do you see that when we split that apart into 2 equations, we're going to have sine of theta equals 1/3 and sine of theta equals 1/2. Okay, good. So we have to find the angles in radians. I think, Lauren, I had asked you this before, but I'll ask you again because maybe it wasn't you. When we talk about numbers 1 to 10, and there's no preference here. 10 isn't better. People solve some equations using the unit circle, and people solve some equations using a reference angle. Where do you fall on that continuum? 5. So I'm pretty sure it was you. We talked about this last week, and it depends on the situation. So what I would do here is I would use the reference angle approach because, everybody, we don't have a choice when it comes to this. We have to use the reference angle for the first equation. The difference here now, Lauren, is we want an angle in radians. So you're going to have to take your calculator, make sure it's in radians, and take the inverse sine of 1 divided by 3. And the difficulty here with a lot of people, myself included, it's complicated, is that I get a number that's not really a number I'm very happy with looking at. It's not like 42 degrees. Because it's a decimal radian value, it's very difficult. But the reference angle for the first equation is that. So let's find the reference angle in decimal form, because it probably does say decimal form. Let's find the reference angle in decimal form for the second equation by taking the inverse sine of 1 divided by 2. Now, many of you should know that the reference angle is 30 degrees. The angle when sine is a half is 30 degrees, but you're not going to recognize it as pi over 6. That number that you're looking at right now, so the reference angle here is 0.524. So I'm going to write those down. Theta reference here is 0.34. Theta reference here is 0.52. In both of these cases, Lauren, the trigonometric ratio that is sine is positive. No, it definitely something happened on my end, Aaron. In both of these cases, the sine value is positive, which means that we are talking about in quadrant 1 and quadrant 2. I don't know how nice this looks. I think 0.34 rads is a lot less than what I've drawn, but I don't care. And then for the 0.52, again, sine is positive, so it's in quadrant 1 or in quadrant 2. Now, if you want to find the rotation angles, the rotation angle is this angle in green, this angle in green, this angle in green, and this angle in green. For the first and third drawings, the rotation angle is simply that number of radians. For a reference angle in quadrant 2, what you need to do is take pi radians and subtract 0.34. So literally what that means on your calculator is you take pi minus 0.34 and pi minus 0.52 to get your answers. So your other two rotation angles would be 2.80 and 2.62. Does that make sense, Lauren? Perfect. Other questions before we move on today?